So good morning. Today we are going to discuss about how to draw OC curve in quality control. So we are going to discuss about drawing of operating characteristic curve. So please read the question, then I can start. Please read it. Read and understand the question before I start the explanation. So before that, I need to share the screen and I will share it now. So can you see it now? Can you
Yes,
see it?
Victor. Yes,
Yeah,
yes.
read 3 times before we start. Okay.
Okay, Victor. Okay.
So a software company wants to produce CDs and each batch, each lot, each packet we can say, each lot consists of 1000 numbers. So Todd Sims, president of Sims Software, has agreed to accept loads with 10% or fewer defectives. So loads with 10% or fewer defectives can be accepted. So in order to do that, they have selected a sample. What is the size of the sample? Out of this 1000 each, they have randomly selected 20 CDs each and examine them carefully. He will accept the load if it has two or fewer defectives. So out of 20, he will inspect 20. So out of 1000, what he will do? He will take 20. He will inspect number of defectives. If it is less than or equal to 2, accept. Otherwise, reject. Clear? So he takes out of 1000 products, 1000 CDs. He take 20 randomly. He check them, he inspect them. Out of 22 or less, okay. For this sampling plan, we call it as a single sampling plan, develop an OC curve. OC curve means operating characteristic curve. What is the probability of accepting a load that is 10% defective? This is the question. We need to draw a curve. The name of the curve is OC curve. What is OC curve? Operating characteristic curve. So if I write the given values, I will write the load like this. I will write it like this. So capital N is the number of products in the load. Small n, small n, small n is number of samples selected. C, the acceptance number is equal to 2. That means from 1000, we select 20 less than or equal to 2, accept. Otherwise, reject. Accept or reject. So this is a plan. We call this as a single sampling plan. Why single sampling plan? Because we take only one sample for inspection. Single sampling plan. We take only one sample for inspection, number less than or equal to 2, accept, otherwise reject. So here for this we have to draw an OC curve. In order to draw an OC curve, we need a distribution called the Poisson's binomial distribution. I will explain to you. This chart will be given to you. I will explain. So before that I need, yes. So here, yes, let us start now. I'm going to write the sample here, plan here. This is the plan. This is a sample size. This is the acceptance number. For this plan, it is 1000. It is 1000. For this plan, we have to draw OC. What is OC? Operating characteristic. Characteristic curve that we have to draw. Operating characteristic curve. How to draw operating characteristic curve is we have to make, or we have to prepare a table. In this table, I'm going to write N. I'm going to write NP dash P dash P dash PA and then multiplication P dash times PA. This is the chart we are going to draw. So I take here N number of observations, P dash is a fraction defective, PA probability of acceptance, etc. What I do, I randomly select probability of acceptance. PA means probability of acceptance. This probability of acceptance is between 0 to 1. So let me take any arbitrary values between 0 and 1. This is, you may ask, this is from where? I have taken this. See 0.70, arbitrarily take this value. So this is not enough. OK, so don't think that this is over. No, we will try to finish within here. OK, this is not.
Doctor, this number.
Yeah,
Assume.
This number assume between 0 and 1. And this is because it is evenly spaced 0.9, then 0. See here 0.5. Then I will take 0.2. Then I will take 0.05. Then the final one 0.02. So 0.02 means 2%. 0.98 means 98, 98%, 95%, 70%, 50, 20, 5, 2. So arbitrarily we assumed some values. Clear? Up to this is clear?
Yes, doctor, yes.
Yeah, now what I do, I will go here. Now I need to fill this table. How to fill this table is, so here small n, number of samples 20, C is the acceptance number, which is 2. So I go to Poisson's binomial distribution here. In this distribution corresponding to 2, okay, acceptance number is 2, right? Corresponding to 2, we have to take the values. See, this is 2. Look at that. This is 2, right? Have you seen 2? This is acceptance number 2.
Yes,
have you seen?
Yes, yes.
You have seen it, right?
Yes.
So corresponding to 2, 98. Which one is close to 98? This one. I have selected 0.98. First one was 0.98. Did you see this? 0.98, correct?
Yes,
in the table corresponding to C, C is 2, acceptance number 2. The value which is very close to 0.98 is 0.9856, correct?
Yes.
So here I will prepare another table. This is only for assumption. 0.9856 is the next table. 0.9856. So what I will do, I will draw another table here. Actually, you have to draw only one table, but still. So n is the number of samples. n p dash. Then we have p dash. Then acceptance. Then p dash pa. That I will explain to you what is p dash pa. So 0.986, correct? From the table. 0.9856. 0.985. What is this value? This is called the NP dash value.
0.5.
0.5. So I am going to write the NP dash 0.5. N is 20. Clear?
Yes, doctor.
Clear, right? Okay. So next value. Next value. Can you similarly can you take what is next value? 0.
0.95.
Yes, come here. Corresponding to 2. This is 2. 0.95. Which one is close? This one is close. See?
Yeah, 0.9526.
26. What is NP dash here?
Yeah, 0.8.
0.8. So 0.9526. NP dash 0.8.
0.8.
Number 20.
20.
Yeah. What is next? 0.7.
0.70.
0.70. Is it available here? 73 is available. Then if it is not available here, come here. Have you seen it? 2 again. 0.7. 0.67 and the other one is 0.
3.
No, here. This one, right?
Yes.
You can take any one of them close to 0.7 or any value. What is one? This is 1.8.
1.8. Yeah.
Yeah. 0.7306. 0.7306. 1.820. What is next one? 0.5.
0.5.
Yeah, where is 0.5? Here we have 0.5. This is the value. 0.5184 and corresponding is this one, not this, huh? This
Yes.
one, 2.6.
2.6.
So 0.5184. 0.5184. 2.620. What is the next one? 0.2, correct?
2. 2. Yes.
Yeah, 0.2 available here to 0.2. Yes, here 0.2381. 4. So 0.2381. It is 4. It is 20. What is next one? Next value 0.5%, 0.05. Maybe not available here. You can go to next one. 0.05. 04 is available. We will take this. 0.0430. Correct?
Yes, 6.5.
0.0430. 0.0430.
5.
6.520. Correct? What is the
Yep.
last one? 2%, 0.02. From where we get 0.02? Look at that. From where? 0.02 from here. How much?
0.023.
Yeah, 0.0203, 7.5, correct?
7.5. Yes.
0.0203, 7.520. Clear?
Yes, doctor, but this table were found
This table I will give you.
nothing from tutorial.
Not available in the tutorial. Now it is there. I will upload it. Poisson's distribution.
Now, yeah.
I will upload it in the tutorial sheet. Near the
Ah.
tutorial sheet. You can find it. Poisson's distribution. Okay.
Okay.
Clear now?
Yes, Doctor. Easy.
Now use your calculator. NP dash you have, N you have. How to find P dash? NP dash divided by N, correct? P dash is equal to NP dash by N. N cancels, that's why. What is NP dash? 0.5. NP dash 0.5 and N is how much? 20. Find.
0.025.
0.025. Okay, then
Then 0.8.
0.
Wait. 0.04.
04.
0.09.
0.09. Okay. Then
2.6. Okay.
2.6 by 20.
0.13.
0.13. Next.
0.2.
0.2. Okay.
0.325.
25.
0.375.
This one, correct?
Yes. Yes.
Now, can you multiply? This is P dash. In order to draw OC curve, operating characteristic curve for a sampling plan, this is your sample. This is your plan. This is your sample plan. What is your sample plan? Your sample plan is out of 1,000 products, you will select 20 as a sample. You will inspect them. You will measure them. If defectives less than 2, you will accept it. Otherwise, you will reject it. This sampling plan, we take sampling plan can be represented by graphically. Graphically means by graph. That graph we call it as operating characteristic curve, OC curve. Clear? Clear?
Yes, Doctor.
Yeah. Now we have to draw this and how to draw it. We have to draw it and how to draw it. That is the thing. Okay. Now what I will do, I will try to escape. Keep. Okay, this will be kept here. Okay. Now what I will do, I will enter. Okay, I'm going to draw the graph now. Please just see how we can draw the graph. Now I need to take this from here. Only this cannot be taken. The whole will be okay. So what graph I am going to draw in here is OC curve, operating characteristic curve, operating characteristic curve. In this curve, I will draw y-axis, I will draw x-axis. X-axis is P dash, y-axis is PA, probability of acceptance. What is PA? Probability of acceptance. We know that probability of acceptance starts from 0, end with 100. So I will put 0, 10, 0.1, 0.2, 0.3, 4, 5, maybe 6, 7, little bit more, 8, 9, and 1, 100. So it is 0 to 100. What are the P dash values here? P dash is fraction defectives. It comes from 0 to 0 point around 4, right? 0.0, yeah, 0.005,
25,
yeah,
0.04,
0.05.
0.09.
Yeah, so
Yes.
how we will draw is the graph, like this one can be, you can put this as 0.05, this one 0.1, 0.15, 0.2, 25, 3, 0.35, and 0.4. Now let us draw, this is what? This is a fraction defectives. We call it as fraction defectives, P dash. Now let us go to fraction defective 0.025, 0.986, 0.025, that means middle. And PA, probability of acceptance is 0.986. How to mark it? 0.025 and 986 closely here. What, clear? I can proceed.
Yes, doctor. Yes.
Now second is 0.04, 0.95.
09.
So, yeah, 0.04 is here, 0.95 is closely here. Okay. Now third is 0.09, 0.73, 0.09 is here, 0.73 somewhere here. Then using graph sheet you have to draw, okay? Then 0.13, 0.5, 0.13, 0.1 here, 0.13 is closely here, and then 0.5 somewhere here. Now then 0.2, 0.23, 0.2 and 0.23 here. And then you have 0.04, 0.3 and 0.04. 0.3 and 0.04 is somewhere here, very low, less than 1. So 0.03, okay. So somewhere here. And the last is 0.02. 0.02 is very small somewhere here. See, starting from 1 and decreasing continuously. Now join them. It will not stay here. It will be like, it will continue like this. This graph, we call it as operating characteristic curve. It represents a plan, your plan to inspect this. For example, if you select a sampling plan like this, a simple sampling plan, then the graphical representation of that will be like this. You can analyze anything using this graph. Analysis means what? For example, a question is given here. What is that question? This question, can you read this? Can you read this? Yeah.
What is the probability
Of
of
accepting.
accepting lot
Accepting
that
means PA. Accepting means PA. If the lot is 10% defective,
10%
means P
defect?
dash 10, 0.1. So corresponding to P dash 0.1, 10% means 0.1. We need to find PA from the graph directly. 10% defective means 0.1 here, right?
Yes.
If you take, draw a line, vertical line, and that vertical line will meet here. This will be the probability of acceptance for that slot.
0.7.
Yeah, whatever you are getting, that is the value.
Okay.
Is that clear to you now?
Yes, doctor.
This graph, you can find anything if you give any defective. Now I want to find how much probability of acceptance, how much acceptance for this slot, n equal to 1000, n equal to 20, z equal to 2, acceptance if it is 20% defectives. If it is 20%, 0.2. Sorry, I have, it is clear.
Yes, doctor. Graphic clear.
Graph is clear. Okay.
Yes.
So like that, you can find anything, any value. This is the graphical representation of a simple sampling plan. Now I have given you one more item here, which is not asked in the question, but if it asks later on, you can find it. Can you calculate P dash times PA? P dash times PA. 0.025 times 0.986. How much?
0.02465.
2465. Okay, what about next one? Very quickly, 0.04 and 0. Multiply these two.
0.038104.
Okay, what about next one?
0.06575.
Okay, next.
76.3.
0.
0.0673.
Okay.
0.0476.
Okay.
0.0139.
0.013.
Okay.
97.
Okay. Last one.
0.375 multiply 0.203.
0.07.
07.
0.007612.
07. Double two zeros are there, right?
double
Yes,
zero.
20.
But what about here? This one, how many zeros are there?
One doctor, yes, correct. Again, I calculate again.
Yeah, this one, can you calculate?
1, 4. Yes, doctor, correct.
0.0139.
Yes.
Yes.
Okay. Okay. Now we are going to draw the figure here, another figure which is not asked in the question. I am telling you, it is called the AOQ curve. AOQ means average outgoing quality. Average outgoing quality curve. What is that curve? That curve indicates P dash PA, the one you calculated now, P dash PA in y axis, P dash in x axis. Similar to here, you can plot 0 0.05, 0 0.1, 0 0.15, 0 0.2, 0 0.25, then 0 0.3, 0 0.35, and finally 0 0.4. So all values you have P dash PA y axis, which are 0. You see here 0.007. Okay. So what you can plot here is 0.005, two zeros, 0.1, 0.01, 0.015, 0.02, 0.025, 0.03, 0.035, 0.04. I think it is enough. Yes. Okay. Up to 6 is there.
Yes, 6 doctor.
Yeah,
Up to
up to 6, 0.045, say 0.05, 0.06, for example.
Okay.
Now you take the values here, P dash, the first one 0.025, P dash, the other one is 0.02465. So you have to locate 0.025. This is here. With what was the answer? 0.025, 0.2465. 0.2465 is somewhere here. Now next one 0.04 P dash, 0.04 approximately. Yeah, 0.04 approximately here.
Yes.
It will not go to that point. Okay, somewhere there. Okay, what is the next one? 0.09, 0.65, right?
Yes.
0.65.
Up.
0.09, 0.65 comes to the top like somewhere here, right? Now 0.13, 0.06, 0.6, 0.13, 0.6, 13 here. Okay. 0.2, 0.05.
5.
Yeah, 0. What is next one? 0.3, 0.13. 0.3 and 0.13. And 0.13 somewhere here. So what you will get, see here, if you join them, you can find something like this, the curve. Have you seen it? The maximum value of this curve, we call it as AOQL, average outgoing quality limit. Average outgoing quality limit. The maximum you can, that means if you draw a vertical here, you will get a value here. How much? Say, for example, here 15%, right? When you draw with the graph sheet, then only you will get actual value. This is not actual, but I am explaining to you. Corresponding to AOQL, if you draw vertical line, you will get P dash. That P dash will be the maximum a customer can say okay to this lot. For example, if it is 0.15, maximum 15% defectives customers will tolerate. Customers will tolerate only up to this. So that maximum limit is calculated. That is called the average outgoing quality limit, the maximum. So when you draw P dash PA with P dash, you will get a curve. We call it as average outgoing quality limit. That curve, average outgoing quality curve. The maximum value is average outgoing quality limit. And here the P dash fraction defective will be the maximum amount of fraction defective which a customer can tolerate. Is that clear to you?
Yes, doctor. Yes.
These are the two curves which are required to study. So I will proceed to this. I will provide it in the tutorial as Poisson binomial distribution. I will give it to you. Now we are going to start with the limits and fits here. Limits, fits, and tolerance. First question, one question we will solve and then I will leave you. So here we need to find shaft tolerance, hole tolerance, and state whether the type of fit is clearance, transition, or interference. Hole and shaft are given. For example, This one, there is no change, right? So this one
Excuse
cannot
me.
be. There is some
Doctor.
mistake. Some mistake here. We will solve this. Okay.
Okay. Doctor,
These are.
record this video.
Yeah. It is recording, right?
Okay. Okay. Thank you.
Yeah. Here, hole. What is a maximum hole? Maximum hole equal to 30 plus 0.05 equal to 30.05. What is minimum hole? Minimum hole equal to 30. It is 30 itself. See, correct? 30. If you take shaft, maximum shaft 30 minus the maximum shaft is 30 plus 0.05. How much? 30.05. Minimum shaft is going to be 30 minus
Yes,
0.02.
yes.
29.98. Have you seen it? Any
Yes.
doubt in this?
No, doctor. Clear.
Yeah. Now calculate minimum clearance. Minimum clearance. There is an equation in the lecture note. Minimum clearance equal to minimum hole minus maximum shaft. What is minimum hole here? 30 minus maximum shaft is 29.98. So you will get 0. How much?
0.02.
0.02. Sorry, 0.02,
No,
which is
no. One.
positive.
Yes. No, correct.
Correct, right?
Yes.
Correct. Okay. Now I go for another interference. If you see that interference equal to, say, minimum hole minus maximum shaft. What you are getting? Minimum hole 30. Maximum shaft is how much? Sorry. I did a mistake here. This is not 29. This is maximum shaft. We have to substitute here. How much? 30.05, right? See, this is the maximum shaft, not 29.
Yes. Mine 0.5.
Minus 0.05. Sign
No,
is
no.
important. Minus 0.05, right?
Yes, doctor.
Okay. Maximum clearance equal to maximum hole minus minimum shaft. Okay. What is maximum hole here? 30.05 minus what is minimum shaft? 29.98. What is the value?
0.07.
0.7, right? Yeah. One of them plus maximum clearance plus minimum clearance minus. Have you noticed it? Minimum clearance minus maximum clearance. Minimum clearance minus maximum clearance plus. Hope that it is clear to you. Minimum clearance is minus, right?
Yes, doctor. Minus 0.
Maximum is positive. Then which type of fit? Transition fit. The final answer is transition fit. Why transition fit? Because one of them minus and the other positive, hence transition fit. Is that clear?
Yes, doctor.
Okay. So if both positive, which fit? Both positive, clearance fit. If both negative, which fit? Both clearance negative, interference fit. If one positive, one negative, transition fit. These are the type of fits we studied before. Okay.
Okay, doctor.
So thank you very much. Ali attended, Khalid attended, Halima attended, Mariam attended, Ahmad Jamal attended. Thank you very much for attending, and we will meet on coming Sunday, right? Sunday.
Yes, doctor. Thank you.
Thank you very much.
Welcome.